Hey guys, I wanted to talk a little bit about the homework today because we didn't really get a chance to in class. So today you're going to figure out the path of a particle in a magnetic field. So we talked before about the force on a particle. Now we want to figure out what it's actually going to do to the motion of a particle. So we're going to start in this case with a proton, which is a positive charge, moving horizontally at speed v, enters a magnetic field. Okay, so first it says, first thing to do, number one, determine the direction of the magnetic force on the proton and represent it as a vector originating on the proton. Okay, I'll actually do this one for you. So let's see. The magnetic field points into the page. The velocity is, which like the current is moving right. So you place your fingers into the page, place your thumb right, and are you doing it with me? You're going to find that the force points up. Yay, that's exciting. All right. But then here's what it says to do. So remember, I represented the force as a vector starting at the proton, right? So it's a vector, and it's positioned over here. Okay. Then it says, place a dot a couple of centimeters beyond the original position where you think the proton will be relative to the dashed line. All right. So the proton was moving this way to the right, and then it was given a force upwards. So where's it going to be now? Well, you're going to figure that out. And actually, I'll tell that to you too. It's going to be like over here. Okay? You put a little positive charge, I guess, if we wanted to, right? It's going to still be moving to the right because nothing stopped that. But now it's going to be moving up as well since there was a force that kind of gave it a kick upwards. And it says, label this position 2. So I'll do a little 2 over here. Estimate the direction of the velocity of the particle at position 2. Well, let's see. Before it was moving to the right, it was given a little kick upwards, so it's going to still be moving upwards because of its inertia, so it's now going to be moving up and to the right. Okay, so there I got that. Then draw a vector representing the magnetic force on the proton. So once again, I'm going to figure out the force when it's over here. I'll draw a force arrow. And then I'm going to figure out, based on the force arrow, where it's going to be later at a position 3. I'll draw a position 3, 4, 5, 6, whatever, until you can decide the general shape of the path, right? So you're going to draw the proton at a bunch of different places along its trajectory, okay? Enjoy, guys.